Okay, topic today is speed of sound. In case of speed of sound, we have to discuss three things. Number one is factors affecting speed of sound. What are the factors then? Number one, temperature. For temperature in your book, the data is given as speed of sound in air at 0 degree centigrade is equal to 331 meter per second. Again, speed of sound in air at 25 degree centigrade is 346 meter per second, and speed of sound at 100 degree centigrade is equal to 386 meter per second. From this data, we make a conclusion, and that is, if temperature is increased, then speed of sound also increases. Even if we know that if we increase the temperature of some gases, their density decreases. Density decreases means their particles move away from one another. So in that way, the speed of sound should decrease because density is decreased. But here, in case of temperature, we see density decreases due to increase in temperature, but the increased temperature also increases the kinetic energy of the particles. Thus, velocity is increased, velocity of the particles is increased, and so the speed of the sound increases when we increase the temperature. Now the second factor we are going to discuss is density or compactness. So second thing we will discuss is density or compactness of particles in gases or liquids or in solids. So here you see, if we have a particular volume, in this volume these are the particles away from one another. But if we take another example, here same volume, but what? Compactness has been increased, that the particles of the medium, it may be gases or liquids or gases, the compactness has been increased. So what will happen? It will transfer compressions and rarefactions more easily. So what will happen? Speed of sound increases when density or compactness increases, and vice versa over here. Speed of sound decreases when density or compactness decreases. This can be applied on number 1, humidity. Okay, what's humidity? Humidity means in air the moisture is increased. When the moisture increases in air, then the density of moist air is greater as compared to the dry air. And that's why the areas which are near to sea or river, the speed of sound will be greater as compared to the speed of sound in the areas which are far away from river or sea, etc. So humidity, if you see humidity is increased, then the speed of sound also increases. We can conclude from here that speed of sound will be increased during rainy season as compared to some dry season. Okay, next number B comes over here in compactness. Liquids. What happens in case of liquids? The speed of sound increases generally 5 times the speed of sound in air. We can say in liquids the speed of sound becomes speed of sound in liquids is equal to 5 times speed of sound in gases. And what is in case of solids? You know, compactness is further increase in case of, this is compactness, further increase in case of solids. So from experiments they have given data in your book that speed of sound in solids is equal to 15 times speed of sound in gases. So if the speed of sound in air is 331 or 340 degree centigrade, 340 meter per second, then the same speed of sound will be increased. Say in seawater, in your book it is given approximately 5000 meter per second. 1531 means 5 times the speed in air. You see, 330 multiplied by 5, it gives 1650 meter per second. But approximately, due to certain factors, it is approximately 5 times means 15 meter per second, and exactly it is given 1531 in your book, 1531. Anyhow, it is a generalization. In liquids it will be 5 times the speed of sound in gases, and what in case of solids it is 15 times. For example, you may say 330 multiplied by 15, it gives approximately 5000 meter per second. So in case of solids, and this is in case of liquids, you have just made approximation. over here, a general formula, that velocity of sound, speed of sound. Why we are using the word speed instead of velocity? Because when we are performing some particular experiment, then we will consider the direction of the sound waves in particular direction. So we will use the word velocity. But generally we see the sound spreads all around us. So that's why we use the word speed in case of speed of sound, and also in case of light we use the word speed of light. But when we are performing some particular experiment, then we are considering the direction of speed of light or speed of sound. Then we will use the word velocity of sound and velocity of light. But generally we use the word speed, even if you know that speed is a scalar quantity and velocity is a vector quantity. Basically, the speed of sound and speed of light doesn't mean that these are scalar quantities. Basically, these are vector quantities. But as we know, sound and light spreads all around the source, and that's why it's better to use the word speed instead of using the word velocity. Okay, here we come towards another thing. Second thing, and that is calculate speed of sound, or you make a question that how will you calculate speed of sound. So remember one thing, there are three words: calculate, measure, and find. The word find covers these two things: you calculate or you measure, you use the word find. But in case of the word calculate, we calculate anything by using a formula, and we measure anything using some instrument. Okay, if I say that calculate the distance from point A to point B, then you will use a formula. And if I say that measure the distance from point A to a point B, then it means that you will have to use some instrument. And when I'm going to say find, then it's up to you whether you use a formula or you use some instrument. Okay, now here when it is said how will you calculate speed of sound, then sometimes students start giving the answer as if they are going to present some experiment. Okay, the measurement is after this topic. We will measure the speed of sound also, but here you will have to calculate speed of sound. How? We will say we know. What we know? We know in the chapter of water waves that velocity is always equal to product of frequency and wavelength. So here we will use this formula to calculate the speed of sound. Just decode these, that where V is velocity of sound waves, F is frequency of sound waves, and lambda is wavelength of sound waves. And that's all. This is how you calculate the speed of sound. Now the third portion is how will you measure. Here the third is how will you measure the speed of sound. So here in this case, this is the word measure is used. What we will do is, first of all, we will perform an experiment to measure the speed of sound. What we have a flat wall over here in front of us, a flat wall, and we are standing in front of that flat wall, and we will clap when needed. We will clap here, and the distance of the wall from us is measured. Again the word is measured. I'm using measured using a tape, measuring tape, and it comes d is equal to 50 meter. Suppose that we are 50 meter away from the flat wall. And next, what the thing, we have a stopwatch. Here we have a stopwatch, 0, 1, 2, 3, okay, 90, 100 in seconds or in minutes or whatever. We have a stopwatch. You may use a digital watch nowadays. This stopwatch is to calculate the time of traveling of the sound waves from your clap up to the flat wall, hitting the wall and then bouncing back and coming back up to you. Okay, what you are going to do is you will clap and ask your friend to start stopwatch simultaneously. Simultaneously means at the same time. You clap and your friend starts the stopwatch. When the sound travels from your clap, reaches up to this flat wall, hit it and bounces back and comes back up to you, then the stopwatch is stopped and time t is noted. Now again, for more accuracy, for precision, what you do, you clap 10 times and then calculate average time as time for 10 claps divided by 10. You see the word calculation is used over here. Why? Because you clap 10 times and you measure the time, your friend measure the time using the stopwatch. But then how you are going to calculate you are going to find the average time. You are going to find the average time by calculation. You calculate it as T average is equal to time for 10 claps divided by 10. It will give you average time for 1 clap. Means time for the sound to start from your clap, reaches up to the flat wall, hit it, and then bounces back and reaches up to you. What the sound is doing is, it is covering double the distance d. So you can say therefore total distance covered is equal to 2d, or you may say 100 meter. Now in data you have two things. Number one, total distance covered is 2d, and number B, average time, say some anything x. So at C you will calculate now. How you will calculate the velocity? You will calculate the velocity as s is equal to vt. We know this formula in 9th class. Therefore velocity comes equal to s divided by time, and here you will use 2d divided by average time, or say this x. You may write t average, whatever. This is the formula that will give you the velocity of sound. And how you calculated this velocity of sound? You calculated this by finding or by measuring s and t average practically. You measured the s and you measured the average time, and then you calculated the velocity by dividing the total distance covered by the sound wave divided by the total time taken. So this is how you measure the speed of sound.